Welcome. I want to talk about orders of magnitude. Order of magnitude. Now what this means is a number that gives us an idea of how big something is. I'll just start off with an example. We might want to talk about the height of a person. I'll just write this down. A human height. Or I might want to think about the length of a bus. A bus's length. Now if I just, everyone has a different height, and some are taller, some are shorter, and so are buses. Some are longer, some are shorter. If I just want an order of magnitude, what it means is that I want a number, just any number, which is not too far off, to give me an idea. So the way to say this is that the human height is, we say that the human height is of the order of 1 meter, and we might say that a bus's length is of the order of 10 meters. Now this doesn't mean that a bus is exactly 10 meters long. It means that the bus it can be a few meters long, it can be maybe 20 or 30 meters long. So it is 10 meters long, give or take some factor of a small number, all right, like 2 or 3 or 4, some number less than 10. So just as for the human height, doesn't mean that if we say that the order of magnitude of a human height is 1 meter, it doesn't mean that every boy and girl and man and woman in the world are exactly 1 meter tall. It just means that they are 1 meter tall up to a factor of 10. So it's like somewhere between a few times of a meter or a few times smaller. But of course we know that it's usually people who are 2 meters or taller are quite rare, and people who are babies can be as short as maybe 30 centimeters maybe, or even less, but not that much shorter. So when we talk about orders of magnitude, we really want a number which is typically written as a factor of 10. So maybe a meter, 10 meters, or 100 meters, or maybe 0.1 meters, or 0.01 meters, and so on. Now, why do we want orders of magnitude? Well, having these numbers gives us a quick way to estimate or calculate things, which we might look at in future videos. But for now, we really need to have an idea of for different orders of magnitude. We need to have an idea of some examples of things or objects that are very small and that are very big, and we need to have an idea of what are their orders of magnitude. So let me start off by looking at some examples. So in fact, I'll start from the smallest. Okay. So let me start from what is something that is really small. Okay, let me start from an atom. So how small is an atom? Now an atom is typically of the order of, right now you see that you have learned how to use the word order, right? So I can say an atom is of the order of 0.1 nanometer. So that's how big an atom is, roughly. Of course, it's not all atoms are exactly 0.1 meter, just as not all people are exactly 1 meter tall. It might be maybe 2 times of that, or half of that, or some small factors of that. Okay, so but it's something which is useful to know if you're learning physics. Now the next example that I want to write down is the thickness of a cell wall. Now you know what a cell is. A cell is the smallest unit that makes up a living thing. Um, Probably from my limited knowledge of biology. So a cell is as in a cell of a living thing. Now, but well, a cell is already quite small. But here we're not talking about the cell. We are talking about the wall of the cell. We're talking about the cell wall's thickness. So that's a lot smaller than the size of the cell. Cell wall thickness, and that is typically of the order of 10 nanometer. 10 nanometer. Alright, now let's move on. We're just going to look at a few examples. Now it is of some use if you can remember at least a few of these for your course in physics. So I'm just going to keep going. Now the next one is virus. Alright, I think most of us know what a virus is about. We probably don't know what it is exactly, but you might have caught a virus now and then, you know, when you have a cold and then you start sneezing and coughing and so on. So that's a virus, and hopefully we don't catch a really serious virus that can be deadly. So the size of a virus is of the order of 100 nanometer. So that's the order of magnitude of the size or the length of a virus. And let's move on. The next thing I'll look at is the wavelength of red light. Now later on, we're going to learn in the topic on light that a light is really a wave, like the kind of wave that you see on the sea or on a pond when you throw a stone inside. So red light is really like a wave. We can't really see it, but we can talk about the wavelength, right? The wavelength is like, you know, if you throw a stone into a pool of water, you see ripples coming out, sort of moving away from the stone, and the distance between the peaks of the ripples, alright, between the neighboring circles of the ripple, that would be the wavelength. So we'll talk about wavelength a bit more next time. So for now, I'm just going to say, right, if you have a wave, I should draw it here just in case it gets confusing. If I have a wave, like a wave from water, the wavelength here just means the distance from the peak to the peak of the wave, for example. So for the wavelength of red light, that means the red color light that goes into our eye when we see a red color object like an apple, and so that red light wavelength has an order of magnitude of about the order of 1 micrometer. Okay, so that's a somewhat abstract example for now. Now next, let me talk about something that you might actually have seen, maybe not directly, a blood cell. A blood cell. So, well, we can't see a blood cell unless you have a microscope, but we might all have seen our blood at one time or another when we prick our finger or when our nose bleed. Okay, so a blood cell has the size of a blood cell is of the order of 10 micrometer. 10 micrometer. Now another example would be of something that has this size would be a water droplet. Water droplet. Now this is water droplet as in water droplet in the air when you spray lots of water, for example. So those tiny little specks in the air, which you might just about see if there is light, if there's strong sunlight, for example. So moving on from there. So let me just change to another color just to make it more colorful. Now the next example that I want to look at is, let's say, the width of your hair. Now if you ever have a hair drop off or plucked off from you or from someone else, you don't notice that it's very, very fine. You can hardly measure it with a ruler. It's a lot smaller than the smallest interval, even the single marking on the ruler. And that is that the hair width is all of the order of 100 micrometer. So that's actually 0.1 millimeter. Okay. Now we might be more familiar with a millimeter. So let's look at a millimeter now. Let's talk about an ant. Now you have probably seen an ant around sometime in your life, crawling around your table or on the floor or even up your hands, and that would be of the order of 1 millimeter. That's for the small ants, of course. I'm sure you might have seen big ants that are as big as 1 centimeter or more. Now, those could be quite painful if you're bitten by them. So let me look at another insect. Let me say a mosquito. Right? A mosquito is probably bigger than a small ant. Now mosquito would be of the order of 1 cm. Hopefully we don't get to see them too much. Some of them can be quite deadly. Now the next thing that I look at is, say, a radio wave. Now if you have listened to a radio or if you have watched television, the pictures and the sound is carried through the air from the station to your TV by something called radio wave. Now radio wave is a kind of wave, I'll talk about that next time, and it has a certain wavelength, the radio wave wavelength. So it's a wave like light wave, okay, and the wavelength of this radio wave that carries our TV signal has an order of about 10 cm. So that's that. It's radio wave. Now let's keep going. Now the human height, I've already talked about that. I'll just write it down again. Human height is of the order of 1 meter. Okay, and a bus. Okay, a bus. The length of a bus is of the order of 10 meters, and let's see, and perhaps a football court. That would be of the order of 100 meters. The actual thing is probably a bit longer, but maybe not more than a few times of 100. Okay, that's that. Now I'm going to take a big jump now to something big. I'm going to look at a mountain. I'm going to look at Mount Everest. Now we know that that's the tallest peak in the world, and that's of the order, the height of Mount Everest is of the order of 10 kilometers. Okay, and it's probably some factor of that, but I don't think it's a big factor. And finally, the last one that I'm going to talk about is Earth's diameter. Earth's diameter. And that must be really big in human terms. And that is of the order of 10,000 kilometers.